Kubernetes pod disruption budget. So before that we need to understand what is disruption. So disruptions are two types. One is involuntary disruption, second is voluntary disruption. So involuntary disruptions are unavoidable, such as hardware failure, or admin deleted the VM, or hypervisor failure, or kernel goes panic error. Due to network partition, your node is gone, or node is out of resources. Second is voluntary disruptions are typically by admin or application owner, basically by the human, such as you drain a node manually, or remove a pod from a node, or deleting a deployment, or delete a pod accidentally, or node software you upgraded and your pod's gone, eviction mode, something like that. So here involuntary disruption, this left side, how you deal currently. So we will make sure wherever the pod is running, it has enough resources, any kind of resources. Second is you will be replicating your application, means pod in a high availability mode, such as in multiple nodes or multiple replica, something like that. Then you will be, for highly availability point of view, you will spread the pods in a multiple racks or multiple nodes. If your nodes are spread across a multiple zones, then you will spread across a multiple zones. That's how you will deal the involuntary disruption. But what about the voluntary disruption, right? So voluntary disruptions are initiated by the Kubernetes admin, right? So if admin is initiated or trying to upgrade a node software by using a kubectl drain, which we saw in the CKA, right? So, or sometimes auto scaling group, auto scaling, say let's say auto scaling is 3 and goes down to 2. In that case, one node will go out. In that case, whatever the pods in that node will go in eviction mode, and defragmentation will happen, and the size will go in a compact. In that case, how you deal such kind of, right? So, and also at the same time I wanted to maintain a high availability. What's the solution? That's what the today's topic, which is pod disruption budget, right? Now pod disruption budget, what exactly it is? In a simple terms, pod disruption VC budget. So it will a budget for voluntary disruptions, which is made by the Kubernetes admin or any human or application owner. So what is, why we do this pod disruption budget is for high availability. So how high availability means, let's say I have a deployment with the 3 replicas. No matter you drain or do whatever, minimum number of 2 always run, which is nothing but we also call as error budget as well. So important if your team has an SLA. So how it is, you will see in detail in the further slides. Basically this pod disruption budget is for high availability point of view, maintaining a minimum number of pods for SLA. Let's say one web application always is up, 100% guarantee. So that's an SLA. If you define this, pod disruption budget is useful. So before going to the pod disruption budget, there is a pod priority. Pod priority, why we use a pod priority? For involuntary and voluntary prior to the pod disruption. So let's go to the Kubernetes documentation. This is a pod priority and preemption, which is introduced in 1.14, right? So now here, pod priority is defined in the form of a priority class, which is a non-namespaced. What exactly it is? So I'm in a 3-node Kubernetes cluster. Say let's say kubectl API resources, and I'll grep for priority, right? Priority class, which is shortcut is PC, and priority class, which is a namespace equal to false, which means it's a global resource, right? So that's what its priority class, which is a namespace equal to false. Now why we use a pod priority class, which is to set importance, scheduling importance. Let's say I have 50 pods. Out of 50 pods, 3 pods I set a importance. How do you set? By using this priority class. So this, how you set a importance? By setting a priority number like a ranking 1 2 3 something like that in a layman terms. That priority number is 0 to 2 billion. So how it is we implement pod priority is, you will create one priority class with a some name and value is 1 billion here. So maximum value is 2 billion. Priority 0 to 2 billion, right? And you will set other global default and this description etc, and you will define a one pod definition YAML file, and you will specify I want my this pod has to set the this is the priority. This is how you will set manually to the whatever the pod you feel is important, so that scheduler, this guy will pick up for scheduling or eviction as well, right? Here preemption is in the is nothing but it's eviction in terms of the Kubernetes language. So preempt is nothing but evict within the brackets they given, right? So here preemption point of view, two things. One is non-preempting and preempting. So for non-preempting, what you will do is you will create a same priority class. Then non-preempting means don't want to evict. You will set some number, and preemption policy never you wanted to preempt, then specify that particular name here. So non-preempting nothing but preemption policy never, this is nothing but will be placed in the scheduling key ahead of a low priority pods. So means just keep the low priority for the eviction. Now system default priority class. So before going to the system priority class, let's say, right, kubectl run. Say I wanted to create a one pod called nginx. The kubectl get pod and my nginx pod is getting created. Just wait a second. Yes, it's created, right? Now kubectl get pod nginx and -o YAML. I wanted to see its YAML. See here, priority is 0 and preemption policy set it as a preempt lower policy. This I haven't set. I just simply run kubectl run. So by default Kubernetes system assigned a priority as 0 and its preemption policy, this is a default policy. So if you create a 50 pods, all 50 pods has a 0 priority, then how you define your pods priority for eviction or scheduling point of view, right? So that's what the you will be creating this kind of a priority class and mapping here, right? Now as we see in the kubectl API resources, right, here priority class has a shortcut is PC, right? So clear, kubectl get PC. PC is nothing but priority class. In Kubernetes there are two default priority classes, which is 2 billion 1000. These are the two priority classes, which is maximum number. This is the two priority class. But who is using this priority classes? Kubectl get pod in kube system namespace, right? These are the pods of control plane, and I wanted to check its YAML and searching for a priority, which is, see, all these pods has a 2 billion priority. System cluster critical, this is the one. System node critical as well. Some are node critical, some are a cluster critical. So which has a cluster node critical is higher number, 2 billion 1000. So this is how a Kubernetes will assign a priority of a maximum priority. 2 billion is a maximum number. That priority will assign in case of if you evict any of the pod, right? That's what the it means. So right, this is a we just seen, right? So what exactly it means? Basically large number of large numbers are reserved for critical system parts. Yes, 2 billion is reserved for the system critical. Should not be normally be preempted or evicted. Yes, of course, if it is given a largest number, it won't be preempted or evicted in terms of this language. I hope this is clear on the priority class. Now, today's topic is pod disruption budget. Then what is the link with the pod priority class? So prior to pod disruption budget, this priority class was there and where you can define. But whereas whenever you use a pod disruption budget, it is supported but not guaranteed. Means you will set a priority and at the same time you wanted to use a pod disruption budget. In that case, it's supported but not guaranteed, which is in the documentation. If you scroll down here, right, pod disruption budget supported but not guaranteed, this line. Now, Kubernetes support pod disruption budget when preempting the pods but respect PDB effort. Means you define some pods and try to apply a pod disruption budget, and some of the pods, let's say in a visual way, kubectl get nodes, say master node, worker node, 3 worker nodes, and I scheduled 3 pods. One pod is scheduled here, one pod here, one pod here, and out of that some of the pods has some higher priority, but I drained this node. Then what happens? If I drain the node, then at the same time I set a pod disruption budget, then how the system will react, right? It will respect the PDB. That's what it's saying. And what happens is, scheduler tries to find the victims. Those PDBs are not violated by the eviction. If any such victims are found, eviction will still happen. So that we will see in the further slides. But for now, the pod priority class is this. Right. Now, lower priority definitely will be removed despite of the PDB is violated or not. So that we will see with the demo, we will understand. Now, pod disruption budget, an example. So let's say there is a one node, pod A and pod X is scheduled, and node 2, node 3. So I distributed my pods in 3 different nodes, 1, 2, 3, and this is another pod. This 3 belongs to one deployment, this belongs to some other deployment. Let's consider. Now what I will do is, I will try to drain a worker node 1. What happens when I try to drain a worker node 1? Immediately pod A specific pod will be created here, and pod X specific pod will be created here, and these two will be deleted, correct? When you do the drain in CKA, we have seen, right? Now node 1 is drained. Now I am in a node 2. I try to, here my PDB is, I wanted to make sure always 2 pods running. That's my criteria of pod disruption. But out of 3, 2 always live, no matter you drain or don't drain, 2 pods should run. In that case, what happens is, here 2 pods are running, here 1 pod is running. My minimum criteria is 2. But when you try to drain it, what happens is, it will try to remove this pod, remove in the sense eviction, but there will be a drain will block with some error message, but still system will proceed to evict, and 1 pod will go in a pending state. Why? Because you are draining, and this pod may move here, and the old pod which will be there as it is, so that this D pod will go here. So this is will happen. Then what is the solution in that case, right? 3 nodes, I wanted to drain these 2 nodes, and whereas my pod should locate in the different nodes. Solution is, Simple. You when you wanted to drain a one node, you make sure provision another node so that the pods will safely move to the other node and you can do the upgrade activity. That's how you will be using the nodes in case of the PDB and you wanted to achieve a highly availability. Now to identify a PDB in Kubernetes, you can use in either deployment or replication controller level, replica set level or stateful set level. You can use, these are the 4 areas you can make use of PDB. Now actual PDB YAML. Here there is a one deployment with a name called web and which has a match selector label here and replicas are 5, right? So I can create a pod disruption budget with a some name and here minimum available are 2, means out of 5 pods minimum 2 always available, means 3 goes down. Also if somebody trying to drain a node, also 2 pods will be available. That's one. Then you can specify this minimum available as a percentage as well. So out of 5 I can specify 75% of a 5. Maybe you can ask me a question, if it is a odd number then how the percentage will calculate. So Kubernetes has some algorithm to make sure rounds some particular number and nearest number it will assign. So for both the most important criteria here to note down is deployment level, whatever the label spec.selector match labels, this particular label should be specified in the pod disruption budget YAML. This is the what the YAML definition, and you go to the Kubernetes documentation right here, right? If you scroll down here, there is a YAML file is here. This is the what the YAML file. Now this is a minimum available. Then is another in the same pod disruption budget is same deployment, same thing. Here instead of minimum available, previous minimum available, here maximum unavailable, means out of 5 pods I am specifying a pod disruption budget that only one I can compromise, rest of the 4 always will be there. No matter drain a node or whatever you do, it will be there. It won't allow you to if you try to drain it. And you can specify the percentage as well. Out of 5 replicas I can compromise on a 25% only. So that means it's called a SLA, right? That's what the SLA you can define. And the same, the match labels are most important with respect to pod disruption budget, where you will map it here and deploy both the deployment and pod disruption budget, right? You can implement the PDB by using an imperative command as well, not only the YAML, which I have a sample YAML which I have taken from the, this is a deployment YAML which is a simple Nginx deployment, and this is the pod disruption budget. Minimum available I specify 2 and minimum available 75%, either number or percentage, or max unavailable either a number or percentage. You can't specify both in a one YAML file, it will give you an error. Now imperative command kubectl create PDB, and that's a PDB name -n namespace selector equal to whatever the deployment specific this match label, and maximum unavailable you can specify either of one. You can't specify both, it will throw an error. So either you can specify how many you can compromise or how many you want. That's what the. So now let's go to the console here, right? kubectl API resources and grep for pod disruption. So if you search for this pod disruption budgets, and shortcut is PDB. So kubectl get PDB right now, right? There is a one already PDB I created, so I'll try to delete PDB, right? So right now kubectl explain PDB, just enter. This is the PDB's definition YAML, right? And in the PDB PDB under the spec, right? PDB.spec, and enter here maximum unavailable, minimum available, and selector. These are the three most important with respect to PDB by using imperative command or YAML file. These are the very simple YAML file. Now let's look at the demo. Now so let's say I have a one deployment with a 7 replicas, which is, go to the YAML file, this is right. So these replicas, this is a deployment with the 7 replicas and 7 pods are created. If you create a pod disruption budget of minimum available 5, means out of 7 you can compromise on a 2, but always should be 5 available. So that means what? Evictions allowed unless if you have a 5 pods, means if 5 green pods are available, then these 2 pods deletion will be allowed. Deletion in the sense eviction. That's the first example, right? Then you can safely, because since 5 are healthy, these 2 it can be evicted if you specify that. Now second case, same, you specify the out of 7 replicas, you specify minimum available 30% only. 30% of the 7 is equal to 2. It will make round percentage of 7, which is 2. So in that case, system will check, yes, 5 pods are healthy, and you try to drain a node, then it will make sure 2 pod will be available. And another example is, I have a 7 replicas deployment YAML and 7 pods are created. Then I specify maximum unavailable or 3, which means max to max 3 pods eviction are allowed. If rest of the pods should be healthy, otherwise it won't allow. So ultimately what it will does is, you specify minimum available or max unavailable, make sure the healthy pods should meet the criteria, then only the system will evict the pods, right? So that's how this particular use case. So it will basically evict the pods. Say here minimum unavailable 3 and you try to drain the nodes, right? Then in that case it will basically evict one by one based on the priority class which you define. If it is not defined, then it will use a random algorithm to evict, but make sure rest of the pods will be live. Here I have a deployment with the 7 replicas same and 7 pods are there, and I specified maximum unavailable 50%, which is nothing but 50% of the 7 number, which is not an even number, which is odd number. Out of 7, system basically will calculate 50% of 7 and which will round the number to 3 or 4, and then it will evict only those number of pods if you try to drain it, which is how it is we will see in the demo. So now I am in a 3 node Kubernetes cluster. So kubectl get node -o. I am in a 3 node Kubernetes cluster, and I have a deployment, which is this particular deployment, which is what I did is I simple Nginx deployment and I put a pod affinity so that it will schedule on this particular every node, right? Kubectl get pod, right? And then only Nginx pod is running, which we created for the testing. So kubectl delete pod Nginx -force, right? Now the pod is deleted. Now kubectl get pod, nothing is running at the moment. Now kubectl apply and then deploy -web. So I will deploy -web dot YAML, right? Oops, sorry, missed that, right? So now the deployment is created. Now kubectl get deployment, kubectl get pod, right? These pods are created, and if I see capacity wide, my 3 pods are distributed in a node 1, node 2, node 3 of my 3 node cluster, right? Here it's a 3 node Kubernetes cluster. So 1 pod is created. Now what I will do is kubectl get PDB, pod disruption budget, nothing is defined. So first what I will do is I will take this pod disruption 1, and out of my 3 pods I wanted to make sure minimum available is say, let's say 3. I will make sure 3. Then what I will do is kubectl apply -f pdb1.yaml, which is this is the pdb1.yaml. Then I will apply. Now it's applied. Now kubectl get pdb. Right now here, if you look at here, minimum available 3, allowed disruptions are 0 disruptions are allowed. That means here 100% minimum 3 means, because actually 3 and my budget is for 3. So now kubectl how to check that? Kubectl describe pdb web pdb, right? If you look at here, total is 3, yes, correct. Desired is 3, current is 3, means I don't want any disruption. So how to verify that? Now kubectl get node ho wide, right? Now this one. Now kubectl get pod ho wide. Now see, kubectl in the CKA we learned kubectl drain. I wanted to drain the worker node 1, right? And when you press enter, basically it will give you an error that you need to use the ignore daemon sets and as well as the delete empty directory, right? And I am using that, right? So what it is doing is it's given me an error. Pod disruption budget is set and it's violating my this one, but still system is trying and throwing an error because it won't allow. Why? Because my budget is allocated for the 3, so means it's not allowed anymore. You will see the error continuously happening. There won't be any evictions anymore, right? It will keep on happening in the loop, right? See, this is error message. Now I will just command C. Now kubectl get pod -o wide. See, my none of the pod I lost. And kubectl get node o wide. Worker node 1 I drained, but still my pods are running even though I pass this. That's the benefit of pdb. So now what I will do is instead of that I will try to so clear kubectl uncordon worker node 1. So yeah, uncordon worker node 1. Now kubectl get node, then my all nodes are up and running. So I'll go to this YAML file. Instead of minimum 3 2, I will make it 2, minimum available 2. Then kubectl apply -f pdb1.yaml, which will update basically. Now kubectl describe pdb. Now what happening is I changed total 3, desired to current 3, of course, but disruption only 1 pod is allowed, not more than a 1. So how to check that? Kubectl get pod -o wide. So pod 1, pod 2, pod 3 is distributed across 3 nodes. Now kubectl drain, instead of worker node 1, I'll just try to do the worker node 2, just anything, right? Now it will allow. Why? Because no problem, right? So if I specify ignore daemon set, right? So now if I specify, then web pod is evicted and node 2 is drained. That's good. Let's see that. Kubectl get pod o wide. If you look at here, node 2 I drain, then immediately the other pod it's moved here. Why? Because it's a 3 node Kubernetes cluster, it has a space over here. So in the node 1 2 pods are running and node 3 1 pod. Now what if kubectl drain worker node 1? If I try to drain worker node 1, what happens is still I have a worker node 3. See here, it's showing me an error that cannot evict, and it will try to evict. Why? Because scheduler found a node 3 is still available. You see node 3. Now node 1 to node 3 all are moved here, but of course it respected the pdb. Whenever you do the drain, it respected. So go to the documentation, right? Here kubectl drain, right? So just I search safely drain a node, and when you click here, right, so configure a pod disruption budget. So here it's clearly specified, right? So basically it will respect a pod basically it will support this one. So now node 3 all the pods are running. What if I try to drain a node 3? Will it allow? It won't. Why? Because unable to drain a node. Yeah, so let me delete empty directory also. Let's keep that, and which is totally it should not allow. See, basically it will try to evict and respect the PDB which we define for high availability point of view, and it will keep goes on in a loop. That's what. And now if you look at here, kubectl get pod void, then it's still there on the 3 worker node. But since we set PDB minimum available as a 2, allow disruption is a 1, right? kubectl describe PDB, right? So hence it is basically it's one pod is goes on a pending, because minimum available we set it as a 2. No matter other one, here availability is a main configuration parameter, right? Not the unavailability. So hence the system is basically disruptions made it as a 0. Why? Because this pod not yet scheduled yet. Then this is the reason it's in a pending state, right? And kubectl get node, right? And then all the 3 nodes are scheduling disabled, but still my application is highly available. Now go to the slides. So this is a 4th. Then there is another criteria. Let's say again the same 7 replicas, right? I set it as a maximum unavailable 0. Unavailability is 0, means I don't want to evict any of the pod, or minimum availability 100, means I want full availability or 0 unavailability. What happens in that case? Means here you are asking 0 evictions. So in that case what happens when you try to drain a node? Drain will be blocked, which is something like this kind of a error, it will throw error. So that's what. Now I hope this will give you some clarity over it. And then how app react to voluntary disruptions. So this is basically, let's say you have one simple pod and you wanted to reduce the capacity by 10%. What you will do? You will create one PDB with the minimum availability of 90%, right? So here 75% I specified, you will specify 90%, means 10% you can compromise. But what if there is a stateful pod, something like a SQL Server pod or any other Redis related pod which is a stateful? What you will do? And you don't want to terminate, but if you wanted to terminate, talk to me, something like that, any scenario in your production. Then first of all, don't use the PDB in that case, or else you set it as a strictly maximum unavailable 0, so that stateful pod will stay safely in your cluster. That's another scenario. Is let's say multiple stateful pods like a etcd DB database pod, or like a Redis pod or Zookeeper, something like a multiple number of stateful pods, and do not reduce the pods with some X number. There is some criteria. What you will do? You will create a PDB with maximum unavailable or minimum availability. You will set it. That's how you will set it to your application. And another one last is, if it is a batch job, right? So what should I do? Job need to complete in case of disruption. What to do? Then don't use it. Why? Because if you don't create a PDB, it will automatically create a new pod, right? That's how the where you can configure that. Now another one is disruptive options, right? Like as we seen in the previous slide. This, say I wanted to drain this node, how you will do? You have to create a failover node, same replica of this, and do the failover, then you safely drain. That's the best practice is given by the documentation. Now another one is how to perform a disruption option. Another way is this. For this, what you exactly require, you need hardware, you need a same EC2 machine, or you need a same whatever the VM or worker node to drain backup node. Otherwise, how? Write code or tell the developers to do the such kind of a disruption tolerant applications. Their code has to deal such kind of, or else use a pod disruption budget. Minimal resources are available, right? So pod disruption budget uses a very minimal of resources, right? This is one of the Kubernetes resource, right? And you it will allow more automation, right? And basically the if still you use that, and disruption tolerant applications are a little bit tricky. Why? Because you need to adhere to the its particular logic. And last but not the least, for this particular pod disruption budget in Kubernetes 1.24, which is scheduled in a future, right? Future gets, there is a new pod health policy which is getting introduced in this particular pod disruption budget, so that you can health policy also you can set that. That is once 1.24 is out, we will have a more information on that. Yeah, that's about this pod disruption budget. I hope this will helpful. Let me know what you guys think. Thank you and bye bye.